Good morning. We will start session 5 on chapter metals and nonmetals. In our previous session, we understood about the amphoteric oxides. So what are amphoteric oxides? Basically, zinc oxide and aluminium oxides are termed as amphoteric oxides because they behave both acidic and basic when reacting with base and acid. That means, example, zinc oxides behaves as an acid if it is reacting with a base, and zinc oxide behaves as an base if it is reacting with the acid. Because we know neutralization reaction gives salt and water. Similarly, aluminium oxide behaves as an acid when reacting with a base and reacts and behaves as a base when reacting with the acid to give respective salt and water. So, and we completed the metals part in the previous session. We also understood about the uses of metals. So, in today's class, we will start about non-metals. We know the properties, physical properties of nonmetals. So, we'll start with the chemical properties of nonmetals. Reaction of nonmetal with oxygen. So, as I have told, reaction of nonmetal with oxygen with other things are quite simple compared to metals. So, nonmetal reacting with oxygen will give nonmetal oxide. We all know that nonmetal oxide are acidic in nature. So, example, carbon plus oxygen gives carbon dioxide plus enormous amount of heat is liberated since it is nothing but a combustion. It is undergoing a combustion. Now, just see here, the first equation tells us that carbon and oxygen gives us carbon dioxide and heat, right? Again, carbon and oxygen will also give us carbon monoxide and heat. How is it possible that a same reaction can give us two different byproducts? That's only because carbon and oxygen gives us carbon dioxide only in the complete combustion, what we can say, in the complete presence of oxygen. Carbon and oxygen will give us carbon monoxide where insufficient amount of oxygen is supplied to it, right? So that we can say here as this will undergo partial combustion. That is why carbon monoxide is liberated, which is very poisonous for animals, what we can say here. That is nothing, even human beings come into it. Sulfur reacting with oxygen gives us sulfur dioxide. This sulfur dioxide, if it is reacting with oxygen further, see, sulfur and oxygen gives us sulfur dioxide, right? This sulfur dioxide, and again if it will react with oxygen, we get sulfur trioxide. This is just for your information. Excuse me. The last one, hydrogen and water will give us, hydrogen and oxygen will give us water. So these are the reactions when a metal reacts with oxygen to form a non-metallic oxide which are acidic in nature. Reaction of non-metals with water. Let's see what will happen when these non-metals will react with water. So, carbon dioxide plus water, or we can say reaction of this non-metal, not exactly non-metal, reaction of this non-metal oxide, I will write here. Reaction of the non-metal oxide with water. Carbon dioxide, that is what we formed here. Carbon dioxide when reacts with water gives us, which acid is this? This is carbonic acid, right? How do we obtain this non-metal oxide? We obtain non-metal oxide when a non-metal reacts with oxygen. So that non-metal oxide when further reacts with water, what happens? We get a carbonic acid. Sulfur dioxide reacts with water, gives us H2SO3. It is sulfurous acid, not sulfuric acid. Sulfurous, H2SO3 is sulfurous acid. Okay. Now if you remember, sulfur dioxide reacting with oxygen again gave us sulfur trioxide, right? If this sulfur trioxide is reacted with water, we get sulfuric acid. So, give the formation of sulfuric and sulfurous acid. You should be knowing that sulfuric acid is prepared using sulfur trioxide with water. Sulfurous acid is prepared using sulfur dioxide with water. So I can say these are the basic reactions of a non-metal with oxygen and non-metal oxide with water. The next very important, now another one which we have here is reaction of non-metal with chlorine. Quite simple. Hydrogen reacts with chlorine to form hydrochloric acid. Phosphorus reacts with chlorine to form phosphorus trichloride, that is 3 times it is. So these are the basic reactions when a non-metal reacts with these things. Nothing much in wide or to understand in detail as we understood in the metals part. The next reaction about a non-metal reacting with a metal. So what happens when a metal and a non-metal will react with each other? They form an ionic compound. Now what is this ionic compound? We will see that. Okay, the last one, that is a metal reacting with a non-metal, which is a very important concept of this chapter. Metals react with non-metals to form an ionic compound. Now, what is this ionic compound? We will understand. First, we will understand the definition. The compounds formed by transfer of electrons from a metal to non-metal are called as ionic compounds. Now, what do you mean by transfer of electrons from a metal to non-metal? If you just recapitulate in the physical properties of metals and non-metals, we said that metals are electropositive and they are donors, right? And non-metals are electronegative and they are acceptors. So that is how transfer of electrons from a metal to non-metal will form a type of a compound, and that compound is called as an ionic compound. Now for example, if I take sodium and chlorine will combine together to form a sodium chloride. Now sodium is a metal and chlorine is a non-metal. So the ions, or you can say electrons from sodium are, what you can say here is, sodium gives some electrons to chlorine. That means sodium is donating some electrons. Since it is electropositive, it has more number of electrons with it. Chlorine has deficit of electrons, so it can accept the electron, so it is electronegative. More about this ionic compound, we will be doing this in our tomorrow's class in detail. So now, let's only understand ionic compounds are the compounds formed by the transfer of electrons from metal to non-metal, right, which forms a compound known as an ionic compound or electrovalent compound. So one example I have just written. So in detail we will be doing with ionic compounds and its properties in our tomorrow's session. So what are ions basically? They are positive or negative charged atoms. They are called as ions. So about ions and ionic compounds, examples, how to form. We also should know how sodium chloride is formed with respect to these electrons giving and taking. We will be doing that in our tomorrow's session. So the last part of the non-metals part is uses of non-metals. We discussed the uses of metals in our yesterday's session. So where are these non-metals used? Now for example, now basic example, if I tell you oxygen, when we use oxygen? We use oxygen for respiration, correct? That is what we know. Then sulfur, it is used in the preparation of sulfur drugs or in the preparation of sulfuric acid, etc. Boron is used in preparing borax compounds or also in the form of some skin ointments we use it. Chlorine we use where? We use it as a bleaching powder, correct? We use carbon as a fuel. We use iodine to prevent thyroid, or we use iodine in the treatment of thyroid diseases. So these are some non-metals where we use it either in our day-to-day life or in the medical field. So this is about non-metals, where we complete the non-metals part, wherein we will be left out only with the ionic compounds, which we will do it in our next session. Then we are also left with the last important part of this chapter, that is metallurgy. How metals are refined and how do we obtain them from their ore. We will do that in the next consecutive sessions. So in today's class about non-metals, reaction of non-metals with oxygen, we get non-metal oxide, and this non-metal oxide reacting with water, what we get? And reaction of non-metals with chlorine, what is the meaning of ionic compound and uses of non-metals we studied today. So any doubt in this session, you can call on the same day of the video set.